Anyways, with that being said, oh, and another thing I thought about was that after I mark your quizzes, I'm actually going to put, I think I'll put the answer key online that I'll go through and explain how to do each question. If you guys like had a hard time with it, like if your marks aren't awesome, and then I'll put that on YouTube, and then you can watch that so that we don't take more class time to review the quiz. Like if you still have questions after you watch it, I'm welcome to help you, but then just to kind of like, help with that. Okay, so it is possible to have two or more EMR waves interacting with each other, which is known as interference. Interference occurs when two waves pass each other. And superimpose to produce a new wave of different amplitude. So say with constructive, say this is +2, this is +2, it comes together to make +4, and then each wave goes its separate way. So B was going this way and it ends up going that way. Here we have, say, +2 and -2. They go together to make 0. And then it continues on. Okay, so we know this is our constructive and our destructive. So now, that was kind of from Physics 20, but now we'll talk about something new. Diffraction is the spreading out of a wave as it passes through an opening. Or the apparent bending of waves around small obstacles. If light was a particle, Young predicted that if he shone monochromatic light, so light of one color, through one wavelength, through two narrow slits, he would expect to see two bright bands produced on a screen on the other side, is shown to the right. However, this did not occur. Young discovered that when monochromatic light passes through two narrow slits, an interference pattern of bright and dark fringes was produced on the screen. Thomas Young demonstrated the light diffracts and interferes. Diffraction and interference strongly support the wave theory for EMR, of which light is a type of EMR. So now these types of slits that they're talking about are like super tiny, okay? Not like big spaces. So with something like this, actually I'll wait till I get to the next notes to tell you about it. So this was what his experiment was like. So the bright areas, so from this diagram below, the bright areas or fringes are called maxima or antinodals, because that's where constructive interference occurs. Now the dark areas or the fringes are called minima or nodals. And this is where destructive interference occurs. So this is kind of what he saw. So let's go through this diagram a little bit. Now this light going through the single slit, it didn't really need this single slit here. If there was no single slit and the light source was just beaming out, it would have made the same result. Okay? So I just wanted to note that you don't necessarily need single slit. Okay, well, regardless, the light waves come out, and there's two slits right here. So if you can see them, here's like an opening, and here's an opening, okay? So the waves go through, and they actually create two different waves, and then there will be constructive. So there's constructive interference, and it's already on a dotted line there for you. Okay, so he would notice it produces kind of these different bands showing
all elementary classes, please make your way down to the music room for assembly.
I thought she was going to say locker room or something. So, I should just say before. So something like where if he looked on the screen, it doesn't line up perfectly with the diagram here, but when he looks on the screen and sees that dark band, this is dark, therefore it's destructive. And here's where it's light, or bright, I should say maybe. This is where it's bright, therefore constructive. So now, every place where there's a constructive interference, we said it's called a maxima, right? Maxima. So we call that like n. We use the variable n to say which maxima it is. This lesson is kind of hard because some of the variables are different. Like n is means something different for these equations than other ones. So just be mindful about which variable is which as we go through. Okay, so each one of these, this one where it goes straight through, okay, it's like right in line. We call this the central maxima. And that's where n, we say, is equal to 0, is like the center one. And then the ones, the next ones right beside, these are n is equal to 1. Oops, not m. And then the next ones are n is equal to 2. So it's like when, yeah, I'll just tell you more. So I'll just put a note here. N refers to order number of bright fringe. So if you're told that you're looking at N3, you know that that's 3 constructive interferences away from the middle.
Would it be like negative if you're going down?
No, it's just looking at it like a whole spectrum. Yeah, yeah, good question. No. Okay, so these are your formulas. So take out your formula sheet and check these out. We're still in obviously our wave stuff. So you can see here's the 2 formulas right there in your wave stuff. Okay. Okay, so and then here's our variables. Lambda is still wavelength, that's normal.